Alrighty, so now that you finished the dice game, and hopefully you were able to check your names and your formulas with me so that you know your dice game was done correctly. I'm going to ask you to now, on the back of your dice game, I want you to write the chemical formula for a compound between these two elements, nickel and oxygen. So go ahead and use your periodic table, find nickel, find oxygen, try to bond those two together. You can pause the video now while you find nickel and oxygen and make those work. All right, so by now you've probably noticed that nickel on your periodic table actually has two different charges. It seems to have a 2 plus charge and a 1 plus charge. It turns out that nickel is stable in both configurations with either a 2 plus charge or a 1 plus charge. So I'm going to have you try to do both. Try to figure out what the formula would be for nickel with a 2 plus charge and what the formula would be for nickel with a 1 plus charge. You can pause the video again and figure that out. All right, so oxygen, we know an oxide ion has a 2 minus charge. So in order to bond a nickel 2 plus ion with an oxide ion, that's really easy. That's just going to be NiO. And if nickel has a 1 plus charge on it, then our formula is going to be Ni2O. So those are the two possible formulas for our nickel oxide. Could you also write the names for these two different compounds? Pause the video now and write the names. So if you wrote the same name twice, nickel oxide, for both of them, I want you to consider that these are two compounds that have different formulas. At the atomic level, they would look quite different from each other, so they probably shouldn't have exactly the same name. Can you try to guess how the names might be different from each other? A common guess that people like to make is they'll say that maybe Ni2O is actually called dinickel oxide. That would seem to be a helpful way to differentiate the two. But it turns out that that's not how we differentiate the two names here. I'll show you how we do. NiO has the name nickel 2 oxide. That's 2 in Roman numerals, so we put it in parentheses. And Ni2O has the name nickel 1 oxide. So that is Roman numeral for a 1. And as you can probably tell, the Roman numeral there corresponds to the charge on the nickel ion. So if the nickel has a 2 plus charge, we call it nickel 2 oxide. If nickel has a 1 plus charge, we call it nickel 1 oxide. Cool? So Roman numerals are necessary when the metal ion can take on multiple charges. So if we look back at our periodic table, we're going to find that lots of these metals here, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, palladium, platinum, gold, indium, a bunch of these have multiple charges that are possible. So for all of those, for any one that on your periodic table has more than one possibility, we need to denote in the name of our compound which charge we have. So the Roman numeral denotes the charge of the metal ion. All right, so let's practice using Roman numerals with our compounds now. I want you to get out that paper that I gave you on Friday, the one that looks like this. And we'll do the first one together. So we want to figure out the formula and the name for a compound containing these two ions, a zinc ion and a chloride ion. So the way we can do that is we can say zinc has a 2+ charge. I can find zinc on my periodic table, and I see that it only has one possibility. It's going to be a 2+ ion. And chloride, of course, is just a chlorine by itself with a 1- charge, just like that. And now we can tell right off the bat that these two ions together are not going to add up to 0 charge. They're not going to be neutral. So I need to add another chloride ion. And now my two negative ones together add up to a -2, which cancels out my +2 from my zinc. So then to write my formula, it's just going to be ZnCl2, just like that. And we can call this zinc chloride. All right, I'm going to let you do the next 3 by yourself. I'm not going to show the answers for those on this video, but you can ask me about them on Monday if you're unsure about your answers. I'm going to jump down to iron now. Why don't you do these 3 before we move on to iron and acetate? So you can pause the video now and run through those real quick. All right, now let's look at iron and acetate. Now, if I find iron on my periodic table, I'm going to notice that iron has 2 different possibilities. All the ones so far that we've done on this page have only had one possibility, but iron can either be a 2+ or a 3+. So I'm just going to take these one at a time. I'm going to do my 2+ first. So I'll write iron 2+. I'll write the formula for my acetate ion, which I can find in the bottom left corner of my periodic table. It's going to be C2H3O2 with a charge of a -1. And just like in my very first example, I'm going to notice that my +2 and my -1 do not cancel each other out. So I need to add a second acetate ion for 2 total. All right, my formula then, Fe, open parentheses, C2H3O2, close that parentheses, and then throw a 2 outside it to show that I have 2 of the thing in the parentheses. In this case, I have 2 acetate ions. And so the name for this compound here is not just iron acetate, but it's going to be iron something acetate. And we always put the Roman numerals in the parentheses to be the same as the charge of the iron, or the charge of the metal. In this case, it's iron. So my name is going to be iron 2 acetate for this first one. Fe C2H3O2 is called iron 2 acetate. Let's do the next one now. We have iron with a 3+, which is the other possibility. C2H3O2 is still the correct formula for an acetate ion. But here we're going to notice that instead of just one more acetate ion, we need 2 more because we have a +3 on our iron this time. So this time the formula is going to be Fe C2H3O2 3. And as I'm sure you can tell, this is going to be iron 3 acetate. Why don't you give the rest of these a shot? For copper, we're going to find that copper has 2 possibilities, a 2+ and a 1+. And for the last one, titanium has, I think, 3 different possibilities. Yeah, it can either be titanium 2, titanium 3, or titanium 4. So you'll have to do that one, 3 of those. Cool. All right, so finish up the rest of this sheet, and then once you are done with that, you can go on to the back here where we have lots more practice. Remember, the Roman numerals are only necessary when we're working with a metal that can take on multiple charges. And we know whether it can take on multiple charges by checking our periodic table. I'll do the first one with you here, and then I'm not going to do any more of these with you. Actually, I'll do this one, cobalt 2 chloride, and I'll also do CuO with you. And then I'm going to ask you guys to do the rest. So cobalt 2 chloride, I know that cobalt is CO. And if I don't know that, I can take the time and find it on my periodic table, because that's what you're going to have to do on the quiz. And I'm being told straight up that cobalt has a 2+ charge. On my periodic table, cobalt has several possibilities, but here I know that I'm working with just the cobalt 2 ion. Chloride never changes. Chloride is always a 1-. So then to write the formula for this compound, it's going to be CO, and I need 2 chloride ions because I need to cancel out the positive 2 charge on my cobalt and chloride. I need 2 chlorides in order to do that. You see that? All right, so that's that one. You can fill out the rest of these using that same process. Now let's jump down and do this one. Here we're going the other way. This time I'm giving you the formula, and we have to write the name. So first, I can write that this is copper oxide, because those are the 2 ions that are here. But I need to check my periodic table and look for whether or not copper can do multiple charges. And it can, indeed. Copper can either take on a 2+ charge or a 1+ charge. So let me look at my, my formula here. Which charge does it look like copper has in this case? Well, oxide always has a 2- charge, and I know that my charges have to add up to 0, so then copper must have a 2+ charge here, because I just have 1 copper and 1 oxide. And if it must add up to 0, then my copper has got to have a +2 charge. So I can write that this is copper 2 oxide, like that. And we can fill out the rest of these just like that as well, keeping in mind that we only need the Roman numerals if it is a metal that can take on multiple charges. Cool? Alrighty, I'm gonna check that you have these done on Monday, so make sure that you have this ready to go. It's my expectation that this is gonna be done, or at least you gave it a really good effort. We'll do some whiteboarding on Monday in preparation for our quiz on Tuesday. Cool? Alrighty, thanks for watching.